judges. I'm Yang Si Hui, and my supervisor is Professor Xie Jianxin. I'm from元智University Department of Mechanical Engineering. And this is my research topic, an assessment of psychological stress by using plethysmography wave amplitude and heartbeat interval. And what is health? What health organization define health is the state of complete physical, social, and mental. And we have to a lot of effort on physical aspects. But how about mental? People suffer a great deal of pressure from surroundings or from their jobs, and that could affect their health. Generally, there are some common methods to assess the mental condition, like questionnaire or consult with mental doctor. This can get detailed information. However, it cannot prove this information whenever or wherever you want. And some people use multifunction monitor by detecting physiological signals like ECG, EEG, or EMG to assess the mental stress condition. But this method is too complex and the machine is high priced. So our purpose is to use our hemoglobin saturation by pulse oximetries. And by grabbing pulse oximetry sensor on our finger, we can obtain the SpO2 signals. So it can be measured easily, and the machine is cheap. Moreover, after doing signal processing, we can quantify psychological stress by a value from 0 to 100, and it can represent relaxed to nervous. So this is my analysis flow chart. First, we extract PPGN plus demographic amplitude and HBI heartbeat interval from SpO2 raw signals. After doing median filter, we do normalization. The normalization is not as usual. We have to build a group database and to obtain a cumulative curve for normalize. And this problem we'll talk later. So finally, we use this equation to compute PSI value, physiological stress index. And this equation is developed by Mr. Hiku during surgeries. And in his journal paper, he found out PPGA and HBI have the most correlation with body stimulant. So he derived the surgical stress index and this equation. And we apply his method on assessing the mental condition. And we will confirm whether it also works. And this is the definition of PPGA and HBI. I use the slope to find out the initial gaping point. Then I can obtain the peak point and bottom point. And according to this definition, doing some operation, I can get the PPGA and HBI signals. Normalization. And this normalization is special. It is because physiological stress index is a relative value. So we cannot compare this value with volunteers themselves. We have to compare themselves and with other people. So we have to build a group database. And the group data include all normal cases that people are not with stimulant, and plus people are under pressure case. And we also have an individual data. The individual data is our target, and then the person is under pressure case, is under pressure. So the process of normalization is bigger. First, we plot distribution of group data and the individual data, the blue one and the light blue one. Then we combine them together. So after combining them together, we cumulating and get this curve. Using this curve, we can get normalized value. Experiment 1. Our experiment 1 is a control experiment. Volunteers are in normal condition. That means they could relax, talk, or use a computer. And the recording time of each case is about 20 minutes. Experiment 2. Experiment 2 is an experimental group. 14 volunteers are in pressure condition. and those volunteers are not use English as their mother language. We ask them to presentation their research with 2 professors in English by Skype meeting, and we expect they would be very nervous. And this experiment was separating into 3 stages. Stage 1 is preparation, about 10 minutes before presentation. Stage 2, presentation and discussion. Stage 3, relaxation, is about 10 minutes after presentation. And this picture is when we're doing Skype meeting. This is the result of experiment 1. Figure A is the process of normalization, and the figure B is the variety of PSI. And we can see this figure. And if we are observing in small scale, the PSI varies severe. But if we observing in large scale, and the PSI now changed a lot. This is the table of the results. And we can see the PSI value is about 1939. And the heart rate is about 73. And this value are in normal range. Experiment 2. We can see this figure, the variety of PSI, and the E is separated into 4 steps: preparation, presentation and discussion, relaxation. And we can see during preparation, the PSI is high, and during presentation and discussion, the PSI is still high, but during the relaxation, the PSI index decreased largely. And then this is the table of experiment 2. We can see during preparation, the PSI value is about 57, and heart rate is 90. And during presentation, PSI is 60, and heart rate is 93. And during relaxation, PSI is 34, and heart rate is 78. So we can find out during presentation, the PSI and the heart rate value is highest, and during relaxation, the PSI value and heart rate is the lowest. So this is fit our expression. And we also use these data values to do ANOVA statistical analysis. If the p-value less than 0.05 was considered, they have a significant difference. And this is our result. And we can see using PSI value, stage 1 and stage 2 are similar. But if we compare with stage 3, we can see stage 1 and stage 2 both have significant difference with stage 3. And the result is the same both in PSI and the heart rate value. And we also compare the presentation and the discussion. We can see during presentation, the PSI value is about 63, and heart rate is 92. And during discussion, PSI is 49, and heart rate is 83. So we think that is because during presentation, 2 professors are focused on these volunteers. So it would be very nervous. But during discussion, sometimes 2 professors are discussed it with each other, and the volunteers are just listening. So maybe it would be not so nervous. And we also use these values to do DDEX, and we can see during presentation and discussion, they have a significant difference both in PSI and heart rate value. So our conclusion, we confirm a new method to assess this psychological stress index by using SpO2 signals. So we only need 1 physiological signals, and we can get mental condition, and it can be expressed by a value so the user can use clearly. Future work. First, we will build more database, and second, we try to implement the method on home care system. It can be used on old people and the patient. Thank you for your attention.